Hi dear students, welcome back to computer science class. We have already started our first chapter, data representation and Boolean logic. Under the topic data representation, we have number systems and its conversions, mainly number systems and its conversions, and Boolean logic, it's all connected to digital electronics and its components. And we have seen all these concepts in detail. Let's have a quick revision on all these topics. Okay, yeah. So first topic, number system. You know what a number system is? Number system is an organized way of representing numbers. And data representation, representing data in computer memory. Representing data in computer memory, and we mainly deal with numeric data, okay, numeric value. And number system means it's an organized way of representing numbers. We have four number systems, mainly four number systems: binary, octal, decimal and hexadecimal. Okay, the name comes from how many numbers are there in the system. Here in binary number system we have two numbers, namely 0 and 1. We know the term meaning of binary. Binary means 2. So here is an example number, sample number 10110 base 2. As we have two numbers in binary number system 0 and 1, the base or radix of the number system is 2. That is why we have written base as 2. And you can enclose it in parenthesis or you can avoid parenthesis. Both are right. Either you can enclose the value in parenthesis or the number in parenthesis, or you can avoid parenthesis. Simply you can write 10110 base 2. That's both are correct, right? Okay. Next we have octal number system. As the name suggests, octal number system is having what, 8 numbers, right? 0 to 7. 0 to 7. Here is a sample number 127 base 8. And why base 8? Because we have 8 numbers here in this number system: 0, 1, 2, 3, 4, 5, 6 and 7. 7 is the last number. Just keep in mind one thing, the base of the number system is 8. So we can have maximum 8 numbers and it is from 0 to 7. Okay, yeah. Then decimal number system, that's the most commonly used number system. We are using decimal number system in all our math calculations, on all real-time calculations, right? So this is an internationally accepted number system. And this is a number system used worldwide for normal applications like mathematical calculations and all other calculations, right? And the numbers ranges from 0 to 9. Total 10 numbers. Yeah. Sample number 235. Okay, here we have two representations. Either you can write 235 without base, which is a decimal number, or you can write 235 base 10. Meaning here you can add base or you can avoid base. Both are same because this is a default number system, meaning when you write a number without any base, it will be taken as a decimal number. But in all other number system, you'll have to specify the base, right? Okay, yeah. And the last one, hexadecimal number system, and it's from 0 to F. You know why it's from 0 to F? 0 to 9. Okay, total we have 16 numbers, 0 to 15. But you can write 0 to 9 as usual, no problem. But when there comes 10, 1, 0, you cannot write 10 as 1, 0 because it will be 1, 0, 2 digits or 2 numbers, right? So to represent 10, we are using an alphabet A, capital letter A, okay, caps A, yeah. So caps A, caps B, up to caps F. Caps A for 10, caps A for B for 11, C for 12, okay. It goes on till 15, that is F. You know the logic behind using what alphabets, right? Because 1, 0, you cannot write 1, 0 for 10, because when you write 1, 0 for 10, what happens is 1 and 0, 2 digits are there to represent this. It won't be taken as 1, 0, means 1, 0 is 10. It will be what? 1, 0, 2 digits or 2 numbers, okay. So we are using A, B, C, D, yeah. A sample number 7BF base 16. 16 must be what? Added, or you can write in place of 16, you can have H, okay. H. Yeah, H for hexadecimal. Yeah, okay. So these are the different number systems, and you can have what? Decimal values as well, like 10110.110. The same way 127.127, not 127, 127.235 base 8. Okay, we can have what? Mixed value, right? We can have point, decimal point. Yeah. Then there are two values associated with these number systems, meaning every number system. Okay, value in every number system. Place value and face value. Face value and place value. You know what face value is? What is the face value of 235? It is 235, right? Let's look at decimal. because we are that familiar with decimal number system, so we can look at decimal. Okay, yeah, 235. What is the face value or the absolute value? It is 235, 235. That is the actual value. That's the absolute value. That is the face value. Okay, but what is the place value? What is the place value of 2? It is 100, right? What is the place value of 3? It is 10. And what is the place value of 5? It is 1. How it is? It's like what? 10 raised to 0, 10 raised to 1, 10 raised to 2. Here in 2, it comes 10 raised to 2. That is 100. It is 200 plus 30 plus 5. That is a 235 is, right? Okay. So the place value of 2 is 10 raised to 2. That's 100. And the value of the place value of 3 is 10 raised to 1. That is 10. And 5, 10 raised to 0. Any value raised to 0 is 0. Is 1, right? Okay. Any value raised to 0 is 1, right? Okay. So what will be the value of this? 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. And for this, 8 raised to 0, 8 raised to 1, 8 raised to 2. For 7, it is 8 raised to 0. It's from left to, means right to left. Okay. We are reading from right to left. So 8 raised to 0, 8 raised to 1, 8 raised to 2. Here for this, for F, 16 raised to 0. Oh, okay. Then B, 16 raised to 1. And for 7, it is 16 raised to 2. We are counting from right to left. But for decimal, meaning, okay, suppose we have a mixed number and we are taking care of decimal point. Okay. From decimal point to left, towards left, it is something raised to 0, 1, 2, 3, 4. And to the right of decimal point, it goes like minus 1, minus 2, minus 3, okay, and so on. Meaning, to the left of decimal point, it's from right to left, 0, 1, 2, 3, 4. And to the right of decimal point, towards right, it is minus 1, minus 2, minus 3, okay, yeah. We can see it in our examples, okay, yes. After that, we have seen two conversions. Conversion between number systems, okay. That's our main topic in under this session, data representation, okay, yeah. So here is our first conversion, binary to decimal, okay, yeah. So here is a binary number. Here we have a sample number 10110 base 2, okay. We are going to convert this binary value to decimal value or decimal equivalent of this binary value, okay. And here is the simplest method. First you just place it again, okay, 10110. Here what is the place value of 0? It is 2 raised to 0, 2 raised to 1, 2 raised to 3, 2 raised to 3, 2 raised to 4, right? Then we are multiplying 1 into 2 raised to 4 plus 0 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus, okay, you know the values. Here it goes like this, 2 raised to 0, 1, 2 raised to 1, 2, 2 raised to 4, 2 raised to 3, 8, 16, like 1, 2, 4, 8, 16, 32, 64, 128, 256. It goes like that. Okay. Yes. So it is 16 plus 0 into 2 raised to 3. It is 0 plus 4 plus 2 plus 0 into 2 is 0. That is 22 base 10. Okay. Here this is how we can convert binary to decimal. Okay. Binary integral part of binary to decimal. Here we have another example. We know this is the fractional part. 0.111 base 2. Okay. Yeah. So how to convert? Here also we are considering multiplication with its power, meaning its place value, right? Okay. So here it is. What is the place value of 1? Meaning here we have the decimal point 0.1. Here it is 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. Okay. It goes on like that. I've already told you before the decimal point towards what left, it goes on 0, 1, 2, 3, 4, 5. Okay, it goes on like that. And towards right, it goes like minus 1, minus 2, minus 3, minus 4. Okay, yeah, and so on. And you know the value of 2 raised to minus 1, it's 1 by 2, that's 0.5. And 2 raised to minus 2, 0.25. 2 raised to minus 3, 0.125. 2 raised to minus 4, 0.0625. It goes on like that. Okay, just half of each value, meaning the half of 0.5 is what? 0.25 is. Half of 0.25 is what? 0.125 is. Half of 0.125 is that? Is what? 0.0625 is, okay? Yeah. So the answer is 0.875. It's simple mathematical calculation, okay? Yes. You can make it fast. You can do it very fast. Yeah. If you're good at maths, okay? A simple mathematical calculation, arithmetic calculation, okay? Addition, mainly addition, yeah. So base 10. Okay, plus we have seen both the integral part and the fractional part. Now you can have the mixed part. Okay, you can have a mixed number like 10110.111, okay, or any other number. Okay, first you find what you can find it simultaneously. Okay, no problem. You can find it for integral part first, then fractional part, then you just join it. Okay, it's of base 10. So here is how we can convert binary to decimal. Okay, now we have decimal to binary. It's another simple conversion. But what decimal to binary, and we have already seen the binary equivalent of what all the decimal numbers up to 15, right? Okay, yes. So here is a method to which we have to look at. Okay, yeah, 25 base 10 equal to dash base 2. That's what our conversion is, because we are converting from decimal to binary. Okay, so 25 here in binary to decimal we have followed multiplication in terms of 2 raised to the power. Okay, yeah, but in decimal to binary we are following division. Okay, the first one is multiplication and the second is division. Okay, yes. So 25 we are dividing by 25 and it gets what, 12. Okay, and the remainder is 1, and 6 it is remainder 0. 6 into 2 12. Okay, 3 into 2 6 0, 1 into 2 2, and the remainder value is what, 1. Okay, here you cannot divide 1 by 2, so in place of this we are writing 0 and remainder value 1, and we consider the value from bottom to top. You can see the arrow. The result is 11001, 11001 base 2. Okay, this is how we can convert what decimal to binary. We are following division by 2. Why it's by 2? Because by 2, division by 2 gives either remainder 0 or 1. Okay, we are converting to binary. You know, binary is having only two values, 0 or 1. That's why we are dividing by 2. That's a logic. That's a logic in division. Okay, in division, in the process of converting decimal to binary. Okay, it's simple. Yes. Just keep in mind one thing. Just after completing our division process, we do consider the value from. We do take the value from bottom to top. Okay. Yes. Now we have the fractional part. Okay, fractional decimal to fractional binary. One more thing, when you convert a fractional value, the result must be also a fractional one. Okay, yes, don't write it as a whole number. Okay, integral part. Here is a sample value 0.8125 base 10. Okay, yes. Just one twist. Okay, here we followed division, here it is multiplication. Okay, multiplication by 2, not in terms of 2 raised to the power, means 2 raised to. Okay, yeah, it is 8. Okay, 0.8125 into 2, we are getting 1.6250. Okay, and we are taking this one out for the answer, as we have taken this remainder for what, the answer. Here we are considering this part, the whole part, the integral part for our answer. Okay, yes, so we are taking this one out, so in effect it will be 0.6250, because we have already taken that one out for the answer. Okay, yes, so then again into 2 we are getting what, yeah, 1.2500. Here also we are taking one out. Okay, so it will be 0.2500. Okay, yes, into 2 we are getting 0.500. Here we don't have 1, it's not 1, it is 0, so 0 will be taken out, it will be 0 point. Okay, yeah, anyway, yeah, so into 2 we are getting 1, and here we followed bottom to top approach, right? We have considered bottom to top, but here in multiplication, in the case of fractional part, we are considering from top to bottom. Okay, top to bottom. Here you can see 0.1101 what base 2. It is 0 point, because we are converting decimal fraction, right? 0 point, so it will be 0. 1101. Okay, this is how we can convert decimal to binary. It's a simple conversion, of course. Yeah. So this is all about converting binary to decimal and decimal to binary. Binary to decimal, it is what, multiplication by 2 raised to the power of. Okay, 2 raised to. Okay, yes. And in decimal to binary, for integral part we follow division, and the fractional part we follow multiplication. Okay. Now we can look at the what other conversions like decimal to octal, octal to decimal. There are a number of conversions. Okay, all are simple. So you just have to practice it. Okay, you can practice any number of problems. Okay, just go through it. Okay, so this is how we can convert what from one means one number from one number system to another number system. Okay, so just go through it. Okay, have more examples and have more practice on this. Okay, yeah. More than that, you must be that skilled in calculation. Okay, basically multiplication, division, addition. Okay, we don't have subtraction here. Okay, yes. So it will be very easy for you when you practice this. Okay, so we can have the other means the coming binary octal to decimal, decimal to octal, all those conversions in our coming class. Okay, so this is all for the time being. Thank you for watching. Have a nice time.